that of any event, probability of any event, suppose you are finding a probability of an event is always greater than equal to 0 and less than equal to 1. It varies from 0 to 1. We are finding a probability of an event. So random experiment we have seen. After that, we have seen the experiments. So when we are performing an experiment, so what are the possible outcomes of an experiment? Okay. For example, if we toss a coin, we are tossing a coin. This is an experiment. Tossing a coin. Okay, we perform this experiment. This is called random experiment. Random experiment, correct? And what are the possible outcomes? All possible outcomes, possible outcomes possible outcomes are either we get head or tail, correct? Head or tail. This is first experiment. Huh? If we are rolling a die, what are the possible outcomes? So all the possible outcomes are it, we have to write what are the possible outcomes. One can come when you are rolling a die or you are throwing a die. You can get one, you can get two, you can get three, you can get five, you can get six, three, four, five, six. Okay, so these are the possible outcomes. So the set, what is a set? Actually, the set is a separate branch of mathematics that you will study set theory in class 11. But here you just know what is a set. Set is a collection of objects, well-defined objects. So collection of well-defined objects. That means here the set of this set we can write this is the set of head and tail. We used to write by using this curly brackets and write the possible outcome inside the brackets and it is noted by S. So this is the set of all possible outcomes. This is what? This is the, we say that this is the set of all possible outcomes of an experiment. Whatever experiment you are doing, all the possible outcomes, if it is written like this is called the set. Similarly here, S is the set of all possible outcomes are 1, 2, 3, 4, 5 and 6. So you are throwing one time die, so you are getting one outcome at a time. If you are tossing two coins together, okay, tossing two coins simultaneously. So what are the possible outcomes? You can have on both the dice head, head. You can have on both tail, tail. You can have one head, one tail, first head, first, second tail, or you can have tail, head, tail, head, tail, head, head, tail, tail, tail. So this is the sample space. This is the set of all possible outcomes. The set of all possible outcomes is called a sample space. Called sample space and denoted by S. That's why I use S. It's called sample space. Okay. And if we take out of this, suppose we are taking from here, if we consider a set of odd numbers, okay, set of odd odd numbers. If you are taking odd numbers, so what are odd numbers? Here 1, 3, and 5. So this set is denoted by event. This is the event. This is the subset. The subset of a sample space is called event. So here I am writing the definition of event is subset of event. Then you can write event is the subset of a sample space. Subset of a sample space. Okay. So in this way, we are finding. So we are always finding the probability of an event. Always we are always finding the probability of an event. Always finding the probability of an event. Of an event. So these all are related actually to theoretical probability. So generally we all have experimental probability. So now we will continue and some questions we will do from theoretical probability also, but after finishing the exercise. Now we have the next question. Yes, we have already taken that the previous. Yes, this question we were doing. Now we can do this question. Here, the number of girls in a family 2, 10 with 2 girls. How many families are there? 475. The families, those are having only one girl child, there are 814 families, and the 211 families having no girl child. Compute the probability choosing at random having 2 girls, probability of 2 girls. Okay. So total, first we have to find here total number of possible cases, total number of possible cases already given for 1500 families. So if you add also 475 plus 814 plus 211, so you will get 1500 families. Okay. This is the total number of possible cases. And first, now we have to find the probability of 2 girls. So you can use P, and inside you can only write the event that you are going to find, whose probability is going to be found. That event you can write inside the 2 girls. So how many favorable cases for 2 girls? 475, and total number of cases are 1500. Correct? If you can convert it into the simplest form, you can cancel it and you can find the solution. Otherwise, you can leave it as it is, because at last they also check the sum of these probabilities should be equal to 1. So that's why that time when you add, no need to find again LCM. So in that case, it will be helpful. But here you can convert into the simplest form, your answer will be 19 upon 60. Probability of 2 girls. So number of families having 1 girl, then probability of number of families having 1 girl. Second, 1 girl. So either you write only 1 girl, or you can write the probability that the number of families having probability of the families of family having 1 girl. 814 divided by 1500, and you can write in the simplest form: 2 4 the 8, 2 7 the 14, and 750. Then probability of no girl child, probability of no girl will be equal to 211 divided by 1500, and it is not further converted into the simplest form. So when the next part they ask, also check whether the sum of these probabilities is 1 or not. So always if this all will be equal to 1 always. So probability of 2 girl child, sum of the probabilities means probability of 2 girl plus probability of the families having 1 girl child, and probability of families no girl is equal to, you can write now, you have to write without converting into the simplest form: 814 by 1500 plus 211 divided by 1500, and then you get take the LCM. 1500 and 475 plus 814 plus 211, so total will be 1500 divided by 1500 is equal to 1. So whenever any experiment is given, then this total, if nothing is missing, this total is always be equal to the given number of families or whatever the data is given for whatever is field, in which field. So then this number should be same, and their probability should be equal to 1 always. This is always happening. Okay, got it? Find the probability that a student of the class was born in August. So total number of students means total number of possible cases. That means, so here in this question, total number of students are, how many students are here? 40 students in a particular class. There are 40 students. Then how many are in the month of August? August, it is showing, we see properly. So the number of students in August is about 6. You can see this. This height is about, from here, if you, yeah, it is 6. So number of students are, how many students are were born in the month of August? August, yes, 6th. So in the month of August, how many students, the number of students of the class was gone in number of students in class 9. Number of students born in August 6. Therefore, the probability of a student was born in August will be equal to 6 by 40. 2 3 is 6, 2 2 is 4. 3 by 20. Okay, 3 by 20. Like this, you can find the probability of two heads. Find the probability of two heads. Two heads. We have to find the probability of two heads. So two heads is 72. So only they have asked the probability of two heads. So we can write here two heads will be equal to 72 upon 200. That means 2 3 is 6, 2 6 is 12. 36 upon 100. Again 2 1 is 2, 2 8 is 16, 2 5 is 10. Again 2 9 is 18, 2 2 is 4, 2 5 is 10. Okay. So directly we can find, very easy. Then an organization selected 2000 families at random. A relationship between the monthly income less than 7,000, monthly income less than 7,000, having zero vehicle 10. So it is given here data. Now findability, the family is chosen earning 10,000 to 13,000. 10,000 to 13,000. This is 10,000 to 13,000. And owing two vehicles. How many two vehicles? Owing two vehicles is 29. So this probability of this even, let's say A, will be equal to 29 upon total number is 20,000. 2,400. Total number is 2,400. 29 upon 2,400. Similarly here, earning 16,000 or more. 16,000 or more. 16,000 or more. Owing one vehicle is 579. So this probability will be equal to 579 divided by 2,400. Similarly, earning less than 7,000 per month. Less than 7,000 per month does not own any vehicle. Less than 7,000, zero vehicle is 10. So this will be equal to 10 by 2,400. You can write in the simplest form. And then 13,000 to 16,000. So 13,000 to 16,000 owing two vehicles. 16,000 is 59. So 59 by 2,400. Now the question is owing not more than one vehicle. Not more than one vehicle means one vehicle and zero vehicle. So how many are owing one and zero? This all will be added. You have to add all these values means how many are having zero vehicle and one vehicle. This all will be added. Add all these numbers here and all these numbers and add that this total and divide it by 2,400. You will get this answer. Okay. So less than a minute is left. You can try the other questions, 7th, 8th. So next time, okay, I will take one more class to complete this chapter next week. Okay.